see, it looks like so far it's just you and me, Haley. So I'm going to give a few seconds for folks to join in. I'm going to get the doc cam fired up. Let's make sure these are open, good. And we're going to start with some announcements, stuff having to do with the test. So I'll go ahead and share my whole screen here. I don't see any real harm in that. Really what we need right now, though, is Senior Doc Cam. ESC 2010 definitely has a lab. Sorry, I got a side conversation going on here. Which class are you talking about, Sweetness? Yeah, 2010 comes with a lab, yep. The one that's on the degree audit? Mm-hmm. I think 1007 also usually has a required lab. Okay, yeah, so good morning, gang. This is, of course, MAC1105, College Algebra. This is the video for section 007. But if you came to this from a link in the 005 section, don't panic. I realized after finishing class this morning that for whatever reason, I think because my client crashed at the boot, it didn't record. So I'm going to post this video for both sections 5 and 7. It'll have the same rough content. I want to start by talking about exam 3. So at the end of the week, last week, we mentioned that exam 3 will be this week. It's this Friday during normal class time, and you have to take it during normal class time. So for section 7 for you guys, that's from 11 a.m. to 12 noon. And it's only going to be available during that time. It will be in my math lab. And you're going to be using HonorLock. HonorLock is a virtual proctoring tool. It's kind of like ProctorU, if you've heard of that before, only it's a little bit less expensive because they employ some artificial intelligence rather than using straight up humans. It is a service that normally costs money. So HonorLock traditionally charges you guys something like $15 per test per person. And so what I've done is I submitted a request to get HonorLock tokens. That's what you can give them instead of giving them payment. Instead of giving them money, you will give them a token when they ask you for your money. I will be emailing those tokens to you individually, either Thursday night or, well, probably Friday morning. Friday morning for both sections. I will email you those tokens. Every person will get their own token. It's going to be a little code that you put in when HonorLock asks you for money. Instead of giving them money, you will give them the token that I will email you individually. So that morning, you'll need to be watching your Santa Fe email for an email from me containing your HonorLock token. HonorLock is a Google Chrome extension. So you need to download Google Chrome, and you need to download HonorLock as an extension. So if you don't have Google Chrome installed on your laptop or whatever, please go ahead today and install it. And then also go ahead and install the HonorLock extension. It's a safe, valid extension. Won't do anything nasty, I promise. You will need a webcam to use HonorLock. If you do not have a working webcam or you don't have access to a working webcam, I need you to contact me through Canvas as soon as you can. Today would be good, Wednesday is okay, Friday is too late. Do not wait until Friday to talk to me about webcam issues if you don't have a webcam. I don't want you to lose any test time to us having to configure the exceptions. So HonorLock will still work if you don't have a webcam. but you need to let me know in advance so I can let them know in advance which students need that particular exemption, and then we'll build some extra restrictions into the browser guard and stuff like that for those people. Or maybe I'll watch you live via Zoom, or we'll have someone from HonorLock review the material, something like this. I don't know precisely what HonorLock does. I just know that if you don't have a webcam, I need to let them know ahead of time, otherwise you'll run into technical issues. I have put together in Canvas, and if you're in section 7, you should be able to see it by this afternoon, a test or trial quiz for HonorLock. So I've created it and I've set it up, but I haven't published it yet because I don't want you guys jumping in there before I have everything all 100% ready to go. In particular, I haven't figured out how to get around the need for a token, but I've been told that if we're just using it as a trial run to make sure everything works, that a token should not be required. This trial quiz, test quiz thingy is not going to count for a grade. This is not an exam, it's not a real quiz. You will go to Canvas under your quizzes, you will open the quiz there, and it will take you then to my math lab, where I'll have a single question that's like, is the sky blue, yes or no? The purpose is just to make sure that your instance of Chrome is working well with HonorLock, and that you don't have any problems going from HonorLock in Canvas to HonorLock in my math lab. So it's just to test the technical stuff. It's not for a grade. And you don't have to do it. If you don't do it, I'm not going to take any points away from you. But you really should do it because we don't want to run into trouble with HonorLock on the day of the test. I will be watching my email and Canvas messages very closely on that day, but if we have to spend 15 minutes figuring out technical glitches, that's 15 minutes of test time that you've lost. If you end up losing a large amount of time, like half of the exam period or something, then we'll figure out some way to do some sort of makeup. But I really don't want to do that. You really don't want to do that. None of us want to have to deal with that shit. So please go ahead and install Chrome if you haven't yet. Install the HonorLock extension. And then once it's published in Canvas, and you should get a little email. If not, just check Canvas, look into the quizzes section. Go ahead and attempt this test or trial quiz for HonorLock. That way we won't run into any trouble. Exam 3 is going to cover material from sections 5.1 through 5.6, which correspond to the homeworks numbered 14 through 21. And I have gone ahead and opened up all of those homeworks in my math lab. So if you want to go back and review any of that material or work a little bit more on any of those problems, you can do so. Those homeworks and the associated quizzes, I think there's 2 quizzes, one for 5.1 and 5.2, and then another quiz for 5.3, 5.4, 5.5, and 5.6, quizzes 5 and 6 respectively, I believe. All of that is open and will remain open until Friday at the start of class. So these will stay open until the test, so you can go back and fiddle with them as much as you'd like to review. An important note, we will be using HonorLock and my math lab for the final. All right, so this is exam 3. We still have exam 4. Exam 4 is going to be like a take-home project type thing. I don't want to give you guys too much like stress-timed exam stuff here in the last few weeks. So exam 3 is going to be a serious timed exam, just like one of our in-class exams, just like the final. The final will be run using all the same technologies. So think of all this stuff that you're doing for exam 3 as also being like a trial for the final. The final exam for college algebra is super tightly departmentally controlled. Everybody takes the same test at the same time, no matter where they are in the world. If you're a Santa Fe student taking college algebra for spring 2020, then you're going to be taking this test at this time. So the times haven't changed. They're the same as they are on the syllabus. And you're going to be using the same system. So it's important that you get comfy enough with this system that when the final rolls around, you don't have any trouble. If you don't have a webcam, you need to talk to me. Another note, if you have any testing accommodations, please message me. So if you worked with the DRC in the past, or you and I had a sort of conversation about potentially working with them in the future, or for whatever reason you had any sort of extended time, distraction-free environment, any rules like that associated with testing, please reach out to me as soon as possible, and I'll make sure to do the best version of that we can in this online testing scenario. So that's this. If you don't have a working webcam, or you don't have access to a working webcam for the test, please let me know. If like your laptop doesn't have a webcam, but somebody in your household has a webcam that you could borrow, then please borrow it. That will make life much easier for everybody. But if you just can't get a hold of one, if there's no way for you to have one for the test, just let me know. And I will talk to the honor lock people ahead of time and make sure that they build in an exemption for you specifically. But it's important that we talk ahead of time. Otherwise, when you try to open the thing, it'll be like, where's your webcam? And you'll be like, shit, I don't have one. And then we'll have to waste test time trying to get this exception built when we should have done it ahead of time so that you don't lose any time on the test. And then, of course, yeah, make sure that we do all this stuff and get it squared away nicely, because the final is going to run in the same way. One last little thing to say here. Before each exam, usually I would give you a project, and then 2 classes before the exam we'll do an activity, and then the class before the exam is a review. So there is going to be a project. Project 3 will be uploaded to Canvas today. It's just like projects 1 and 2, where I give you, a few pages worth of questions to answer that are relevant to the exam, similar content, tries to cover all the important stuff. But of course, I'm not handing you a physical piece of paper, and you can't hand me a physical piece of paper back. So I know not everybody has a printer. I'm not going to require you to print these out and then scan them or anything. But what I do want you to do is write out your solutions, then scan those using an app like Cam Scanner. That's the one I like best. Or Tiny Scan. Whatever you want. Just look in your app store. I use Android stuff, so I know Cam Scanner for Android is really good. Tiny Scan works reasonably well. I'm not sure if either of these are free for everybody. I got a free version of this due to the coronavirus bullshit. They're being nice. But search in your app store, find a high-rated scanner app that is free. Write out your solutions to the project on paper, scan them using one of these apps, and then submit those scans.
Could we use Word and then save it and then submit it on Canvas?
If you want to use Word, so unfortunately, like the stuff we're doing right now involves some pretty heavy algebra with all the logs and exponentials. If you have a way of typing mathematics in Word, that you are certain is readable and understandable, then I would be okay with that. But really, I would prefer to see your handwritten work. The idea of the project is usually for me to see some of your handwritten work and get a feel for your style and be able to help you out a little bit with notation. So I wouldn't say like, no, I'm not gonna like take off points if you happen to submit a PDF of a Word document. I am going to restrict the submissions here in Canvas to PDF only. Because JPEGs, like crappy pictures of work, those are impossible to decipher. So if you insist on doing it in Word with something like math type, or if you're comfortable with LaTeX or some other math typesetting system, and you want to do it on the computer and hand in a digital thing instead, just export it as a PDF first. So I would prefer the handwritten stuff. But if you want to use Word or something like that, make sure that you're typesetting the mathematics well. Make sure that I can read it and I can tell like what's an exponent and what isn't. Sometimes if you're not used to typing math, that can be weird. And then export it as a PDF. And yeah, I won't reject anything. I will take whatever I get and do my very best to interpret. Just make sure that whatever you're submitting is clear.
Okay, thank you.
Yeah, of course. All right, so this is the kind of infrastructure surrounding exam 3. Any questions on any of these things? Okay. All right then. So today would normally be our group activity day before the test, but since we are not in corporeal form, I cannot shuffle you into groups and hand you papers to work on. I would like to kind of just make this like a soft review day where we talk about a few problems and look at some concepts. So I want to know what's going on in your brains. What stuff from the recent homework has been bothering you? And in what sense has it been bothering you? So maybe a problem or two to look at carefully and some concepts to discuss. It doesn't have to be a specific problem from the homework. You can ask me, can we do one like this, or one that involves that formula, or one that involves this technique? Just give me a feel for where you guys stand with this material. What's scary? What sucks? What's easy? What's good? What do we want to talk about more? No wrong answers here. Just let me know what you're thinking. Literally anything. What are we thinking about? Expanding logs? Yeah, those log properties. Expanding and contracting, that stuff's hard. All right, we'll start there. If you think of anything, concepts, particular problems, problem types, formulas that you want to talk about, just type it into the chat. Okay. So this is a big, scary expand the log problem. It's a natural log, and then inside the natural log here, I have the square root of x times parentheses 1 minus z squared, and then all of that is being divided by y to the 5th. So I need to think of those properties of logs. Remember, those properties say that the log, no matter the base of a ratio, say like x over y, that's the log base a of the top, minus the log base A of the bottom. We have a property that says the log base A of x raised to the y is the same as y times the log base A of x. And then we also have a property that says that the log base A of a product, x times y, is the sum, log base A of x plus log base A of y. So these are our three properties that we can use to do this stuff. And I like to work from the outside in. All right, I do see there's quite a bit of activity in the chat there. I will look through and grab a few of those to play with here in just a second after we finish this. So when I look inside this logarithm, to me what appears to be the outermost operation, and it really is just a visual thing, is that division. So I'm going to use the rule that says division inside the logarithm is the same as subtraction outside the logarithm. So this is the same as the ln of that top, which is the square root of x times 1 minus z squared minus the ln of the bottom. So that's my first step. Log with a fraction inside is the same as the log of the top minus the log of the bottom. From there, this first piece has some multiplication inside. And I know that multiplication inside is the same as addition outside. So the ln of, and these parentheses are so important, right? Because they tell me what's inside the log and what's not. So this is where the inside of that first log starts. This is where the inside of that first log stops. And there is multiplication in here. So the ln of square root x times 1 minus z squared is the same as the ln of the square root of x plus the ln of 1 minus z squared. And then I still have this minus ln y to the fifth hanging out. Okay. Now there's a little bit more that can be done with each of these. This first guy, the square root of x, is the same as x raised to the 1/2 power. So I'm just going to clean up inside each of these logarithms a little bit. So that's a log of a power plus. The thing that we can do with this middle term is very subtle. I can factor the inside to create multiplication. 1 minus z squared factors as 1 minus z times 1 plus z. So here are the parentheses that tell me what's inside the log. And what's inside the log when I factor that is this product of two things. These are being multiplied. So I'll be able to do something cool with that. And then this ln y to the 5, I'll just leave him hanging out. So my next step here would be to do with each of these things what these rules tell me I can do. That middle rule tells me that this power can come down front here, and that this power can come down front here. So maybe I'll do that in one step, just applying one rule at a time. This middle guy I'll leave alone for now. And then this guy will be, this 5 can come down, so I'll have minus 5 times the ln of y. And now to deal with that middle term, the cool thing here is that this is also ln of a product. So I can use this last rule to split him up as 1/2 times the ln of x plus, and now this will get split into the ln of 1 minus z, and that multiplication inside becoming addition outside, ln 1 plus z. And then finally, I have my minus 5 ln y. And if you're looking for a good problem combining logarithms, on a separate sheet of paper, write down this line and try to combine. See if you can get back to where we started. So getting comfy playing around with these properties of logarithms, definitely important. Important in this class, super important in the next class, important in calculus, and believe it or not, important in statistics also, where we like to transform things to look at logarithmic scales. So wherever you're going in your math universe, these things will matter. All right, let me see what everybody else wanted to do. So we're going to have about 25 and 23 from 19. Those are, I think, some word problems involving exponentials. First homework's in the chapter, so some 5.3 stuff again. Question 8 on the quiz, condensing logs, 16 through 21. Okay, so let me jump back to some of that 5.3 stuff. I actually have a problem in mind that I would like to play with. Suppose, so this is early 5.3, and then we're going to also have a little bit of 5.5 and 5.6 tying in here. My car is worth $7,000 right now. Each year, it loses, say, 4% of its value. I want to do two things. First, find a function to model the value of my car after X years. So I'm losing 4% of my value every year. Right now I'm worth $7,000. Can you find me a function that will tell me the value of the car after 2 years, 3 years, 4 years, 5 years? And then also, when will my car be worth only $3,000? Okay, so two questions. First, can you find a function? So this is an early 5.3 thing from the rate formula stuff. We talk about growth rates, growth factors. And then second is going to involve solving an equation. It's an equation that we would have solved back in 5.3 using the calculator. We would have graphically estimated when my car would be worth $3,000. But now that we have logarithms, we can treat this like a 5.6 question, like a homework 21 question, where you just straight solve the equation. So let's take a look at this. The formula I need to find the model, to find the function, we begin with the rate formula. Remember, if I have some quantity that is growing or decaying at rate r units per year, or r units per unit of time, then he will follow this formula. F of x equals c, which is your initial value, times 1 plus r to the x. All right, so here c is the initial value. And r is the growth or decay rate. The thing you have to be careful with here is that if you're decaying, that's actually, you're going to treat r as negative, or you're going to subtract there. So we use the plus if growing, and we use the minus if decaying. So does everybody remember this formula? This was one of the first exponential formulas we gave. We learned it on the same day that we learned the half-life and doubling time formulas. Those were all together in our first full lecture on 5.3. I have the information I need to plug into this formula. So for our problem, the value is decreasing. So we're going to use the minus. Not the plus. Also, I know R, my rate, is 4% per year. And so as a decimal, that's 0.04. And my initial value, the value of the car right now, the value of the car when x equals 0, 0 years have gone by, is 7,000. I'll leave off the dollar symbol here and just work with the number. So first, any questions about how we go from this word problem to knowing to use this formula? And any questions about how I'm getting those constants out of the words? This is important. If you have questions, it's a great time to ask, good time to talk. Remember, this is supposed to be like one of our group activities where everybody's talking to each other and I'm also going around answering questions. So please be candid. There are no bad questions, no bad comments. Anything you're thinking or wondering, I want to hear about it. So do your peers. So if there aren't questions, I'm going to go ahead and plug these things into my formula, and that will give me the function that models the value of the car. C is 7,000, and that's being multiplied by 1 plus r or 1 minus r all to the x. So here, because we're decaying, we're going to use the minus. So this is 1 minus r is 0.04, and then all of that is raised to the x. So the test was the first thing we talked about. The test is going to be this Friday in my math lab. You're going to use Honor Lock. I'm going to post this video to Canvas in just a minute. So please rewatch this whole video and you will see all of the important details about the test. There's quite a lot to know there. So please, 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 if you didn't catch the start of the talk here where we talked about the test, please rewatch the video. So simplifying this formula, I get 7,000 times we got to follow our order of operations, right? So 1 minus 0.04, that's 0.96 to the x. So this is what we're after in part A, right? Really just this piece. This is the function that I want. This is just the unsimplified version. Either one would be considered a correct answer. But to solve the second part, to find when the car will be worth $3,000, we need to solve. We have to set up and solve an equation. So there's kind of two important bits to that. That's setting up the equation, figuring out what equation you need to solve, and then also the actual solving. If this is the value of the car after X years, and I want to know when the value of the car will be equal to $3,000, I need to set this, the value of the car, equal to $3,000. So I need to solve the equation 7,000 times 0.96 to the x equals 3,000. And this is now the type of equation that we learned how to solve exactly using logarithms in homework 21. That's what we should have been working on over this weekend and hopefully getting more comfy with. We did solve some of these graphically back in section 5.3, but now that we know how to handle these with logs, there's no reason to ever solve them graphically. We just solve them exactly using logarithms. Remember the trick to solving an exponential equation? We want to get this x alone. So first, I get the term that has the x in it, the 0.96 to the x alone, and then I'm going to do something to get x down out of that power. But before I can get x down out of that power, I need to get the exponential term by itself. So I need to start by dividing both sides by 7,000. So if I divide both sides by 7,000, over here the 7,000s will go away, and I just get 0.96 raised to the power x is equal to 3,000 divided by 7,000. 3,000 divided by 7,000 can simplify quite a bit, though. That's 3 times 1,000 over 7 times 1,000. That's the same as just 3 over 7. So this is 0.96 to the x equals 3 over 7. I'm going to continue this up here. From this step, I want to get my x now down out of this power. I've got the term with the x in it isolated, and the trick to getting something down out of an exponent is to take logs. So now I'm going to take logs on both sides. And I could take whatever log I wanted. I could take the base 2 log, log 2, or I could take the ln of both sides, or I could take the common log, the log of both sides. I like ln. So I'll take the ln of both sides. Usually you'll use either the ln or the log, the base 10 common log, because that's what you have a button for in your calculator. So when I take the ln of both sides, I get the ln of 0.96 to the x equals ln of 3 over 7. And then one of my rules for logarithms says that the log of a power, ln of this raised to the x, is the same as that x coming down, ln of 0.96. So this is how the left-hand side simplifies. That x comes down out of the power and in front of the log as a multiple. And then the right-hand side hasn't changed. It's just the ln of 3 over 7. Now this ln of 0.96 is just a number. It's some number. I don't know what that number is. It's just some number. And this thing over here is just some other number. So think of this as being like x times 5 equals 12. You'd just divide both sides by 5. So I just need to divide both sides by this number, which is the ln of 0.96. So my last step here, I will get x equals the ln of 3 over 7, all divided by the ln of 0.96. And remember, ln is a function. It is not a number or a variable. You cannot cancel those. That is not multiplication. This is not ln times 3/7 over ln times 0.96. It's the ln of 3/7 over the ln of 0.96. It's a meaningful difference. ln on its own has no meaning. It is not a variable. You cannot cancel it. You can't do any of that shit with it. So this is it. This is done. This is done. There's no log property that will allow you to combine these in any nice way. This is your exact answer. Done. Often, though, we want a decimal approximation because I have no idea how big that number is off the top of my head. So I'm going to swap you guys over to my calculator here, and we can do this calculation together. So I'm going to hit the ln button and then type 3 divided by 7 and close that parentheses. That's my numerator. And I want to divide that whole thing by, and you see why this parentheses is so important. Without this, we would get into trouble. I want to divide that by the ln of 0.96. And I close that parentheses also, so my syntax makes sense. So the numerator is the ln of 3/7, just like we have written here. My denominator is the ln of 0.96, just like we have written here. So I hit enter, and I get 20.76. All right, and these are, of course, years. This is the number of years it would take for my car to depreciate from its current value of $7,000 to the value of $3,000. Okay, so kind of two questions in one here. The answer to the first question is in that first box. The answers, plural, to that second question are in the second box here, with the exact answer being the one given in terms of logarithms. This is the exact answer, and this would be the approximate answer. We like to always give this also because who the hell knows how big this is? Even me, with all my experience with logarithms, I look at this and I go, ah, shit, I don't know how big that is. I better write it as a decimal to get a feel for it. Okay, questions about this problem? What we did. PEMDAS is very much still considered in these problems. We're still doing the parentheses first, and then exponents, and then multiplication. So when I go to compute, like this number right here, if I wanted to find f of 2, I would have to first do what's inside these parentheses, right? 1 minus 0.04 is 0.96. That's my parentheses. And then I would raise that to the 2. Then I would do the exponent, so PE. And only then could I multiply by 7,000. So that's the PEM in PEMDAS. It might feel a little bit different because we're not used to having so many exponents. We're not used to having exponents as a variable. And definitely when it comes to things like these logarithms, there is no L in PEMDAS. We're not quite used to seeing logs, but all the same rules still apply. And when you come to doing your calculations, it's the same sort of thing. So like down here, when I went to calculate this number, the ln of 3/7 over the ln of 0.96, I first had to tell it to calculate the ln of 3/7. That's the parentheses 3/7 that you see around here. And then down here, these parentheses. So first we're taking what's going on in these parentheses, then we're taking the logs of them, and then we're dividing them. When I put it in the calculator like this, it's with the knowledge that the calculator will follow the order of operations. John asked, will we have to know the equations for this test? If you mean the formulas for exponential functions, yes. Yes, you will need to know the following formulas for the test. You'll need to know the definition of an exponential function. And you should know here that A is called the base and is also called the growth or decay factor. And that C is called the initial value. You'll need to know the rate formula. That's f of x equals c times 1 plus or minus r to the x, where r is called the growth or decay rate. C is always called the initial value, so I'm not going to keep writing it. I guess I will. You'll need to know the half-life and doubling time formulas. So half-life We always use the variable t because we're always talking about time, because we're talking about things that happen over time. Yes, sure. Sorry, I forgot that I'm screen sharing everything. So here, K is called the half-life, and C is again the initial amount. All right, so you need to know the definition of an exponential function, and you need to know that the number a there is called the base and also called the growth or decay factor. If a is bigger than 1, then that is a growing exponential, and we call it a growth factor. If a is smaller than 1, that is a decaying exponential, and we call it a decay factor. Then you have this rate formula. If you have some quantity that starts out with an amount c and is growing or decaying by r% per unit time, then it will be modeled by this exponential function. And we use the plus if growing and the minus if decaying. The doubling time formula is f of t equals c times 2 to the t over k. Here k is called the doubling time. It's the time it takes for the quantity to double. C is, again, the initial value, or initial amount. So if I told you that I had some population that doubles every 12 years, then you would use this formula, and k would be 12. If I told you I had something that decays by half every 5,000 years, you would use this formula with k equal to 5,000. What else did we have from those sections? We have the rate formula, the half-life formula, the doubling time formula, and we had the compound interest formula. It said the value of the account after t units of time would be p times 1 plus r over n raised to the nt. This is an r. Where p is the principal, or the initial amount. R is the interest rate. Sometimes called the nominal rate, the named rate, to distinguish it from the effective rate. And n is the number of compoundings per unit time. So if you're measuring time in years and you're compounding monthly, then n would be 12. And then the last one is the continuously compounded interest, which is also sometimes called the continuous growth rate formula. This is for any problem where they tell you you're growing at the continuous rate of da 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 da, or you have continuously compounded interest. We call this C of t, and it is p times e raised to the rt, where here p is the initial amount, just like in the other interest problem. It plays the same role as C does in these other problems. R is the continuous rate, might be an interest rate, and here positive if growing. If I told you something is decaying at the continuous rate of 4%, then you would use R equals negative 0.04. So it's negative if decaying. So these are the exponential formulas that you are going to be expected to know for exam 3. These should all stick in your head pretty well after you do the homework. As long as you've gone through and honestly worked all those homework problems to the best of your ability, then it shouldn't be too difficult. I did post the last video, but I just posted it this morning. I didn't get around to uploading that to YouTube until this morning, but it is there now. I can take a look after class if you're having a hard time finding it. So yeah, these are the formulae that you're expected to know, along with the properties of logs that I wrote on that previous page when we worked that last problem. So that is where we run out of time for today. On Wednesday, I want you guys to bring lots of problems that you want to look at. All of the homework and quizzes for exam 3, including homework 21, have been extended to Friday. So you don't need to stress about any of that. If you did not get to watch the beginning of this video, you must watch it. I'm going to upload it to YouTube right away. You must watch it because it contains a lot of important details about exam 3. So that is it for today. If you have any questions, please Canvas message me or come by. I have an office hour tomorrow from 9 to 11 a.m. It's that same link. If you don't get admitted right away, I have a waiting room set up for the office hour so I can talk to people one-on-one in case they want to talk about grades. If you don't get admitted right away, just hang out for a second, and I promise I will admit you. But yeah, that's where we're going to hang it up for today. Bring questions that you want to work on to Wednesday, and we will try to work as quickly as we can through as many as we possibly can. If there are particular problems that you're especially worried about, you want to make sure we get some extra time talking about them, don't wait for Wednesday. Come to my office hour tomorrow and we can talk about those one-on-one, and that will be more helpful. All right, so I'm going to go ahead and end the meeting now. I will post the video for this on Canvas, the same place where you found the link to join the stream, okay? All right, that is it for today, guys.